current inside the conductive metal of the coin, which causes it to slow down a little bit and bypass this chute and continue into this one, where the coin is accepted. The coin then drops into the hopper, where the payphone waits until the switch tells it whether to put the coin in the coin box or return it into the return chute. Now this payphone is ready to make phone calls from home, but that's not really much fun. What I want to do is modify this payphone so it requires coins to make a phone call. Since there's no totalizer, I'm going to have to add a sensor to detect coins. I'm going to put one here on this little flapper. The sensor I'm going to use is a break beam sensor. There's an emitter and a detector, and when an object goes in between, the sensor goes off. Cut a flap out of a piece of card. The flap will be glued onto the hopper trigger right here. Glue the flap onto the hopper trigger.
And now it's time to solder.
First part is the power supply. So this is the coin detector and phone controller that we started with. As a power supply, I'm using 4 AA batteries connected to the battery pack. This is the power supply. It's just a capacitor just to regulate the power and a little indicator LED to tell me it's on. Then I've hooked up the sensor that will detect when a coin has gone down the slot. That's connected to a latch which will take the small pulse that comes from the sensor and convert it into a steady voltage, which then controls a telecom relay. That's a relay that's specifically designed to control the high telecom voltages, and it'll work off of 5 volts. That's perfect. So testing the sensor by putting a card in front. Now I'm going to glue the sensor into the payphone. And now I'm going to glue the other side of the sensor. Make 2 wires with spade lugs on the end. Connect one of the spade lugs to the phone line ring and the other spade lug to the payphone ring. Now plug in those 2 jumper wires into the relay. Now clip the coin relay open. Now it's time to test our system. Turn on the battery pack and pick up the phone. There won't be a dial tone. Now press on the coin hopper trigger so that the sensor is broken and you'll hear a dial tone. Now I'm going to put the payphone back together. Insert the coin validator, close it up. Now nobody can make a phone call on my Skype payphone unless they put in a quarter. Now put in the coin validator. Make sure to be careful of the sensor you placed in. Finally, wire up a bump sensor between the power from the battery pack and the circuit board, so when the switch is depressed, power to the board gets cut. Glue the sensor so when the phone is on hook, the switch is depressed. To make wiring easier, I'm going to crimp on some lugs onto the switch contacts. Thread these wires through the small hole in the payphone bottom. And thread the power connector up. This payphone didn't come with a coin box, so I'm going to use a blue cup instead. Just put it in the back. Finally, stash the power supply and the circuit board right in front. Put the front of the coin box in. Unlock it again with the T key. Slide it on. And lock. Now close up the payphone. Oops.
It's really heavy.
No dial tone. insert a quarter. Now I got a dial tone, can make a phone call. This project is done. So my payphone project works pretty well, but I want to add a little bit of old school charm to it. Instead of the coin going directly into the coin box when you put it in, I want it to sit in the hopper. And then when the phone is hung up, the coin relay will activate and the coin will drop into the coin box, making that nice ka-chink sound. Time to crack open the payphone again. This is that coin relay that we clipped open. Now, I'm going to unclip it. To actuate this relay, I need 130 volts, but I don't really have 130 volts kicking around here because this isn't hooked up to a payphone phone line. The phone line can generate 48 volts, but it doesn't have enough current to drive the relay, so I'm going to have to build my own DC power supply from the battery pack in the coin box. First thing I'll do is build the high voltage power supply. Basic DC-DC boost converter based on the LT1073 chip. This chip actually does almost all of the work. All that's required is an inductor, a Schottky diode, and some capacitors for the input and output, and resistors to set the output voltage. The input battery pack power comes in here, and the output 30 volts comes out of these screen wires. Before wiring this up to our existing circuit, I'm going to test the voltage, just measure with a multimeter the voltage between the two green wires. Should be around 30 volts. Now is a good time to test the DC-DC boost converter. Connect up the converter to the switch so that it's only powered when the phone is on hook. Remove the spring from the coin relay, and then try testing the two prongs to the coin relay and make sure it activates. Plug in the power so it's only activated when the phone is on hook. Remove the coin relay return spring. This will make it easier to activate with lower voltages. With the coin in the hopper, connect the 30 volts output to the two connectors for the relay, G and this 3 here. The relay should activate. Once it's been verified to work, attach the prongs permanently. Connecting them one way makes the coin go into the coin box. Connected the other way, the coins will go into the return chute. One of the nice things about the Western Electric payphone designs is that there's a little reed relay right where the coin detector is. That means that once the coin relay activates, this disconnects and the relay automatically opens. I'm going to cut this board down a little bit. This will make it fit nicer. And I can use the extra scrap for another project. Then put the circuit board in a little baggie. This will protect the high voltages from touching some other part of the circuit board. Okay, put everything back in the coin box, and we're going to close up the payphone and test this last mod. Time to try it out. Pick up the handset and deposit a coin. Now the coin is in the hopper. Hang up. The coin will be deposited in the coin box. So I've got this payphone. It's been modified for home use, and I've taken it and reverse engineered it and made it so that it now requires coins to make a phone call. And I've also added the coin hopper and coin relay activation. But there's one more hack I want to do on this phone. But before I get into that, it's important to understand how these dumb payphones keep track of how much money's been inserted. In this payphone, the totalizer has been taken out. It normally sits here, and it has little arms that stick into the coin validator so that when a coin falls through, it triggers and sets off the coin tone oscillator, the pink box here. The coin oscillator is a passive oscillator that generates 2200 hertz and 1700 hertz. You can trigger the coin tone oscillator pretty easily. Connect one diode to pin 7 and another diode to pin 4 of J2. Clip pin 7 to the tip and pin 4 to the ring. Now when a quarter is inserted into this payphone, the totalizer detects that and it triggers the coin tone oscillator. For a quarter, it triggers it 5 times. Now, That tone goes down the phone line and is detected by the switch on the other side. The switch looks up the current call rates and determines how much money has been deposited and how much money is owed, and asks the user to please deposit more money if necessary. In the late 80s, some clever person either read the Bell Systems manual or deduced how payphones work from observation and determined that if you played those 2200 plus 1700 hertz tones into the microphone, it would go down the phone line and the switch on the other side would be fooled into thinking the totalizer and coin tone oscillator made those tones, and thus was red boxing born. Red boxing became much more popular when it was noticed that the dual tone multi-frequencies from the coin tone oscillator are directly proportional to the tones generated when you hit the star key on a phone. And those tones are directly proportional to whatever crystal oscillator is driving the DTMF encoder chip. So to make these special coin oscillator tones, you don't need a coin tone oscillator box. You could just use a DTMF generator, like this old Radio Shack tone dialer. This one's 16 years old. All you have to do is change the crystal. So open it up and swap out the old crystal for this, a 6.5536 megahertz crystal. Now the dialer will emit the same tones necessary when you hit the start key. Now, due to various anti-fraud measures, the emergence of COCOT, and AT&T discontinuing their payphone line service, red boxing is a rarity. It's pretty much impossible to do anymore. That's a real shame, because I've got one of these red boxes and I'd really like to use it. So what I'm going to do is I'm going to modify this payphone so that I can red box out instead of putting coins in. You don't have to build a circuit that detects the red box tones and play into the microphone with the handset. To do that, I'm going to use a DTMF decoder chip. These are the chips that were used in old voicemail systems, like pressing 1 or 2 or 3 would open a mailbox or close it. I'm going to use this chip, but instead of using the crystal that's supposed to be used with it, I'm going to change it to a different crystal. This is the same one used to hack red boxes. So now both of them are listening for the same frequency tones. Now all I have to do is detect when the star key is pressed. That's the same as a red box tone. Okay, now's a good time to test the red box tone detector. Here's the circuitry for the red box detector. Now I've got the DTMF decoder with a new crystal, so it can detect red box tones. And I've got this selector latch, and that will make sure that only when the star key is pressed will the latch go high. And here's a little indicator LED. This will blink when it detects a red box tone. That's very useful for debugging. To connect up to the handset and listen to the audio coming in from the microphone, I'm going to jack it into this terminal block. Now, this is the reference ground, number 11, and this red wire is from the handset, and that comes from the microphone, so that's going to be our audio input. I've disconnected the ring line from our relay and jumpered it just so we can do this test without having to worry about the relay turning on and off. Okay, pick up the handset, and there'll be a dial tone, and you'll see that this board is lit, but the green LED is not on. Now, red box. You'll see that the green LED lights up because it detected the star. So that's our system. System seems to work, but there's one problem. Now, because the payphone is designed to be coin first, that is, we don't connect the phone line until we get money or a red box signal, there's no power to the microphone, so the circuit can't actually listen in on the microphone because there's no power. But we're going to solve this pretty easily by biasing the handset ourselves by using a 5-volt power supply. Luckily, the internal power supply for the handset is supposed to be 5 volts, so it's kind of a lucky coincidence. First, I'll connect my audio input to the circuit. That'll come from here, the handset ring. Now I'll connect the ground reference prong. That goes up here. Now I'm going to connect the bias power to the handset. That goes into the handset tip. Now this telecom relay is a double throw. That means there's actually 2 switches inside, and I'm going to use that second switch to connect and disconnect that bias power. So only when we don't have the phone line connected here will there be power to the handset. This way, our 5 volts won't compete with the phone line 5 volts. One more thing to do, and that's close up the payphone. Okay, project's done. I'm ready to use it. Pick up the phone, no dial tone, get my handy red box. Now I'm ready to call some confs.
Okay, so that's our video.
What I like about this video is
The way it's displayed here, it's kind of like Hong Kong style, like it's a little bit